Alright, for our last example, we are going to be taking it a step further, where we've previously looked at empirical formula, so the lowest mole ratio possible. Now we're going to be looking at the molecular formula, which is to say what's the actual proportion of the atoms of different elements within a compound. So in this example, we are told that hydrogen peroxide is made of 5.03 grams of hydrogen and 79.87 grams of oxygen. Its molar mass is 34.01 grams per mole. Find its molecular formula. So the first step in any molecular formula problem is we first need to determine the empirical formula. Alright, so I've gone ahead and just done the empirical formula calculation off camera to save some time, since we've already seen a couple examples of that. So we figure out that there is a 1-to-1 molar ratio, and therefore the empirical formula in this compound is HO. So our next step, to find out the number of atoms of each element in the actual compound in its molecular formula, we need to look back to the molar mass. So first, we're going to find the molar mass of the empirical formula, and then we're going to compare that to the molar mass of the actual molecular formula. So the molar mass of HO, it's the molar mass of the hydrogen, 1 hydrogen plus 1 oxygen. And what that ends up being equal to, approximately, we'll say 17.0073 grams per mole. So now we're going to take this, we're going to divide the molar mass of the actual molecular compound by the molar mass of the empirical formula for the compound, and that will give us a multiplier to be able to determine what's the actual molecular formula here. So the molar mass of hydrogen peroxide divided by the molar mass of HO, which is the empirical formula. So 34.01 grams per mole divided by 17.0073 grams per mole. And then when we solve that on our calculators, we are going to end up with a final answer of 1.999729528, and we're just going to round that off to 2. So what this 2 means is that this is the multiplier which we apply to each subscript in the empirical formula. So once we find this number, each subscript in the empirical formula is multiplied by this. So if we have what is basically H1O1, we multiply the subscripts by 2, right, because we've determined a 2. That will give us a molecular formula of H2O2. And therefore, the molecular formula of hydrogen peroxide is H2O2. Make those look a bit more like 2's and a little bit less like a Z. Alright, so that's our final answer there, H2O2. You'll notice how it's still a 1-to-1 ratio within this molecular formula. So the empirical formula of this still is HO. If you were ever given something like this on its own, like H2O2 and like what's the empirical formula, you would know that it's HO because 1-to-1 would be its lowest terms. But the actual molecular formula in terms of how many atoms of each element were actually present in that compound, this is our final answer here.